Now moving further into the topic, let's discuss some more about tension and velocities at some specific points. So here in this diagram we are given with again the velocity at the bottommost point equals u. Here it's u, and at the topmost point let's say it is v. Now for us the task is we need to relate the tension at the bottommost point, tension on the string when the particle is at bottommost point, and tension in the string when the particle is at topmost point. Now we know the general equation of tension is this one, T minus mg cos theta equals to mv square by r, and here the cos theta corresponds to the angle, this one, the angle which the instantaneous position of particle makes with the downward vertical, this downward vertical. So this angle right here is theta. Now if we talk about the bottommost position of the particle, then the value of theta, it is actually 0 degree. It is the downward position. For the downward position, the value of theta is 0 degrees, and if we put 0 in this equation here, we will get T1. Let's say tension for this is T1, this position of string. So T1 minus mg cos 0, which is mg, T1 minus mg equals to mv1 square by r. Let's say velocity at the bottommost point u corresponds to v1. Similarly, for the topmost position, let's say the velocity v corresponds to v2, it equals to v2, and corresponding tension here in the string is T2. At that position, for the topmost position, this angle theta will be equals to 180 degree. Again, if we put 180 degree in this equation and the tension value as T2 and v value as v2, the second equation we get will be T2 minus mg cos 180. So as cos 180 is minus 1, so minus of minus 1 will become plus, so we will get T2 plus mg in that case. So the second equation we get is T2 plus mg equals mv2 square by r. Now considering this the first one and this the second one, if we subtract equation 1 minus equation 2, if we subtract these two, we will get this equation as T1 minus T2 equals 2 mg plus m by r taking common from this part, m by r taking common, we get v1 square minus v2 square. Now we know if velocity here is v1, velocity here is v2, then v1 square minus v2 square will be equals to 2gh, where h is the height between the elevation difference between these 2 points, right? So here in this case h equals to 2r. Now let's put those values. So instead of v1 square minus v2 square, we put the values 2gh, and instead of h we are putting the value 2r. So this equation here r and r got cancelled, so we got 4 mg and here 2 mg. Total value we get 6 mg. This means the difference between magnitude of tension for the bottommost point, bottommost position of the particle, and for the topmost position of the particle, in these two cases the difference between magnitude of tension will be equals to 6 times the weight of the particle. Now this is one relation between the tensions. Now let's talk something about velocity. Now suppose the particle is able to cover the entire circle. In that case, the minimum possible value of velocity of speed, let's say speed, the minimum possible speed that should be given in this position u should be equals to 5 gr, right? So let's talk about this case. If the velocity here is root over of 5 gr, then what are the velocities at c, at d and at a? Now for a we already know this value. This value is equals to root over of gr. This has been discussed in the previous video. Now here let's talk about c and d. From the symmetry we can see the elevation of point C and point D both are same from B. Hence in both these cases the magnitude of speed will remain same. Now if we use our shortcut that v square minus u square equals to 2gh, so in this case the elevation h will be equals to 2r. So we can put the values u square minus v square equals 2gh, and u value is root over of 5 gr. So root over of 5 gr here, u square, instead of u square we are using the value for 5 gr minus 2g into h value is r here. So 5 gr minus 2 gr equals root over of 3gr. That means the speed at C and D, they will be equal to root over of 3gr. But pay attention guys, this value is root over of 3gr only when the value of speed here is root over of 5gr and value of speed here is root over of gr. So these four values are correlated. Now suppose someone asks what should be the velocity here so that the particle can just reach maximum up to C or D. In that case, our value, for that value, see here we have to assume if it reaches just this point, then here the final velocity of the particle should be 0 so that it can return back. In this case, if we conserve our energy, if we use the energy conservation equation, we will get that u value should be equal to root over of 2gr, and this value of speed will let the particle reach maximum up to C or D. Okay, so we should not get confused with these values, root over of 2gr and root over of 3gr. Root over of 3gr is velocity at C when velocity at the bottommost point is root 5gr, and root 2gr, root over of 2gr, this value is the velocity at the bottommost point if the particle is just able to reach the point C or D. In that case we use this value.